Hello and welcome to this lesson about counting. The learning target for this video is using different methods to count outcomes for probability problems. So first of all, let's address the question why. Why do we need to talk about counting? Well, it all has to do with what probability is. So you have to remember that probability is equal to a ratio of desired outcomes over all the possible outcomes. Now, counting helps us figure out all those different possible outcomes. Counting finds all possible outcomes. So that's why we're going to talk about counting here. Now, we're going to start off with a really key idea, and it is called the fundamental counting principle. And the way it works is we essentially multiply a bunch of different things together. So let's try that down. Multiply different options together. And that's it. Okay? So, for example, let's talk about something like rolling 2 dice. Well, when you roll a dice, you have, for that first one, 6 options for how it can go down. The second one, if it's a 6-sided dice, is still 6 options. And so if we want to figure out how many there are overall, you multiply them. And by doing that, right here, we're using the fundamental counting principle. Let's imagine people at a table. Let's say we have 4 people, and they could sit at a table here, and there's 4 options. So how many different ways could they sit at this table? Well, if we look at this spot right here, this is the first person to walk in. The first person who walks in the room will sit there. Any of the 4 can sit there. After that, the next spot, only 3 people are left, so any 3 could sit there. And then here, only 2 people can sit there. And finally, you have the last person who must sit there. Well, again, if we want to figure out how we can kind of rearrange these seats in the seating chart, what we would do is take 4 times 3 times 2 times 1. And that is the fundamental counting principle. It'll tell us how many options there are. So go back to the first one, we have 36. We go back to this one, let's see, that's 12 times 2. So we'd get 24 different ways that 4 people can sit at a 4-person table. And so this leads to all our possible outcomes. That helps us set it up. Now to kick it up another notch, I want to introduce a classic example, and it is the menu problem. I don't know if problem is necessarily the right word, but maybe the menu example would work. But let's say that we have a menu at a restaurant, and on it you have 4 different appetizers you can choose from. And after the appetizers, you have 3 different entrees you can choose from, so main courses. And then you have 2 different desserts you can choose from. And so the menu problem is how many different meals exist. Again, we're trying to find all the possible outcomes for the meals. And then maybe we have a question about, how many have a certain appetizer, entree, or dessert. But in order to figure out the probability of that, we need to know how many there are total. Well, here, again, we just take our different options, 4, 3, and 2, and we go 4 times 3 times 2, which is still 24. And it could change. So, maybe a different restaurant, they only have 3 appetizers, maybe they have 5 entrees, and they have 3 desserts. If that's the case, we can, same thing, you just multiply them, 3, 5, 2, 353, I should say. And in that case, that's 15 times 3, which is 45. So there'd be 45 different meals. Now this leads us to tree diagrams. So I'm going to copy the menu example, and I'm going to add an extra detail to it. So here's that menu: 4 appetizers, 3 entrees, 2 desserts. Now the difference is I've added an extra little detail here: chicken, steak, fish. All right, that's what the C, S, and F stand for. Those are the entrees. You get chicken, steak, or you get fish. Now, let's say that we wanted to figure out the probability of having a meal with fish in it. Now, a tree diagram is great for visualizing all this stuff. So essentially, it's the fundamental counting principle visually drawn out. What we do is we start off with the first thing: 4 appetizers. So 1, 2, I have to scroll down, it kind of takes a lot of space, 3, 4. All right. Now, with that 4 appetizers, each one of these branches, and so this is appetizer number 1, number 2, number 3, number 4. You could order any of the 3 entrees. So we'll have 1, let me draw that like that, boom, 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 and a little lower, boom. So you can see these take a lot of space. Now, each one of these branches here represents either chicken, steak, fish. Chicken, steak, fish, chicken, steak, fish, chicken, steak, or fish. And then after that, we go to the 2 desserts. So 2 more little branches coming off for that. Now at this point, if I wanted to, I could count up all these final little branches that I've made right here. And what that represents is how many different meals I could have, where, we just kind of mapped it out. We start at appetizer 1, and then we can get the different entrees, different desserts, appetizer 2, and repeat and shuffle. But again, we could just use the fundamental counting principle and realize that we have 24 meals. And actually, let me lower that down here. 24 meals. Now, the question we had is, what's the probability of a meal with fish? Well, the tree diagram helps us visualize it and see it. So here is 2 meals with fish, 2 more meals with fish, 2 more meals with fish, and 2 more meals with fish. So I have 1, 2, 3, 4, 5, 6, 7, 8. 8 fish out of 24 meals. So the tree diagram helps us see all of this, and then it can help us cook up a ratio like that, which we would then reduce to, you have a 1 out of 3 chance of a meal containing fish. So that's one variation of counting. The next, fancy counting within groups. So let me propose this situation. Actually, we're going to put a line in the sand here. So we have 12 students and in a class, and let's say for like a service project, 3 of them are going to go tutor a younger grade. And then, so 3 tutor in, we're going to say same room. Compare that to 12 students again, and we need 3 tutors, but 1 tutor is they're all going to go to different rooms. So 1 will go to like 1st grade, 1 will go to 2nd grade, and 1 will go to 3rd grade. Now let's think about how we can extract, or how many different groups we can come up with here. And the thing is, we have a line in the sand, and on the left here, order doesn't matter. Doesn't matter. It doesn't matter how I pick people. All 3 of them are going to the same room. Whereas on the right, order does matter. All right, and so what that ends up meaning is, like, the first person I pick, they're going to go to 1st grade. But if I pick that same person in or 3rd, they're going to 3rd grade. And so that's a different order. That's a different roster, if you will. And if we're looking at situations like that, what we end up getting is fancier phrases here, and this is why it's called fancy counting. The one on the left is called a combination, because we're trying to figure out how we can make a combination of a group of people. where order doesn't matter. Now, if order does matter, the fancy phrase is permutation. Now, we're not going to get into the formulas here because there's something really cool, a button on your calculator that does it for you. So the way it works is you're going to look for a button that says NCR or NPR. And here's how we use it. N represents the number we're dealing with. R represents the number we want of a smaller group of, the smaller grouping. So I go to my calculator and I type 12 NCR3. And that will tell me how many different ways I can get a group of 3 people out of a group of 12. And believe it or not, there are 220. Now, let's look at NPR. Same idea. I'll go 12, take my large number, type in NPR on the calculator, select that button, and then 3, meaning I want to make it groups of 3, but here order does matter. And if I do that, I'm going to get a slightly different number. And this number is actually going to be bigger because the order does matter. And this is crazy. There are 1,320 different ways I could do this. Now again, the reason why we're doing this is we're curious how many possible outcomes there are. NPR, NCR, they help us do that. So right now though, all we're really going to focus on is typing it in and being able to calculate that using the tools at our disposal, aka calculators. Finally, to wrap everything up, when to use what? So when do we use what I like to call what is called the fundamental counting principle, FCP, versus when do we use NCR or NPR? The big difference is all about groups. So if we are using different groups, we will use the fundamental counting principle. Okay? And so if we think about it, we have going back to the menu example, appetizers, entrees, desserts. These are each different, distinct groups. And within here, we had a certain amount of each one, and we're going to pull from those different groups. NCR and NPR is when we have the same group, and we're going with, we're pulling from within it. And so we only have group A. And in the example I used earlier, it was all about, you had 12 different students. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we're just taking a group of 3 of them, whatever group of 3 we can. And it's all within the same group. So if it's within the same group, we use NCR, NPR. If it's different groups, we use the fundamental counting principle. So that's how we count for probability. Good luck with your homework or practice, and let me know if you have any questions.